Well, hello guys, here Mr. G with another question, this time for the grade 12, and this one was question 2 from the Western Cape question paper done in September 2023. Alright, so this is Newton's law, but before we carry on, don't forget to subscribe to the channel so you can get the notification and videos I post on regular basis. I will leave the question in the description below so you can answer before watching the video. The question says a 50 kilogram metal container is dragged to the right across a rough horizontal surface with force of 300 Newton, acting at an angle of to the surface. The frictional force acting on the container is 180 Newton and the acceleration of the container is 2,038 meters per second square. Let's write it here on the picture so we know the acceleration is equal to 2,038 meters per second square. That is the acceleration of the object. Okay, and we know that it is moving in that direction to the right. State Newton's second law of motion in words. Alright, so here is Newton's second law in words. When a resultant force, now the word resultant force is important, you cannot miss that word. If you miss that word, you will lose 1 mark. Is exerted on an object, the object will accelerate in the direction of the force. An acceleration proportional to this force and inversely proportional to the mass of the object. There guys will be 1 mark for this one and 1 mark for that one there. But the word resultant force must be here, otherwise you will lose 1 mark. Question 2.2. Draw a label free body diagram representing all the forces acting on the block. And we can do it on this side here. We can do it on this side here. What forces are acting on the block? First of all, you can see the applied force here. The applied force which is pointing with an angle. This here is the applied force, which we can write applied force FA or just F. What are the forces there? Well, we can see clear here the frictional force. Frictional force pointing to the left. We have a normal force. And we have weight. So these are the forces. Important. Once more, this one is question 2.2. Important. If there are 4 marks, there are 4 forces. 1, 2, 3, and 4 forces. Okay? So quite simple. Prove that the angle is equal to 20. Now, to do that question, the first thing we're going to do is to copy the free body diagram. But in this free body diagram, I'm going to break the force into components. And I will have here the x component. This one will be FA in x. This one is theta. And FA in x will be equal to FA multiplied by the cosine of theta. Alright? And here, if we break in the y-axis, we will have, this one is pointing straight. So let's fix this one here. There we go, and this one is F in Y, and you need to know that F in Y is equal to FA multiplied by sin of theta. So using either one of this one, we can then calculate the angle they're asking for. So let's begin with the x-axis. So we are going to apply Newton's second law in the x-axis, because if we do this one, we're still going to need the applied force. It is there. So we are going to apply Newton's second law to the x-axis. And guys, the x-axis is this one here, in which we have the applied force in the x-axis and we have the frictional force. You don't have to do any of this. You will get used to as soon as you see the pictures here. So question 2.3. First of all, I'm going to start Newton's second law. F net is equal to ma. There we go. I'm going to work in x-axis. You do not have to write this one. I write it, but you don't have to. Okay? So what forces are in the x-axis here? There is the applied force in x. I'm going to write Fx minus frictional force, and that is equal to ma. Alright? So if we go here and we break that formula there, I'm going to move it to the side. We can have that the Fx is Fa multiplied by the cosine of theta minus the frictional force and this is equal to ma. We don't have to write that on there anymore. Okay, so the applied force, we have all the data here. The only thing we don't have is the angle. So when we substitute, it is going to be 300 cosine theta minus frictional force is 180 minus 50, no minus nothing, or equal to 50 multiplied by the acceleration, which is 2,038. There we go, and the rest is mathematics. So here, and this is then 20,0 degrees. That is the answer here. If you do this question in this way, the marks are as following. Let me just look quickly here. You will get 1 mark for the Newton's law. You will get 1 mark for the substitution in the left hand side, which means all this one will carry 1 mark and this one will carry 1 mark, and then that's the 3 marks. Remember, you get 20. You must get 20 because that is the question. Okay, so let's go to the next question. Calculate the coefficient of kinetic friction for the metal container and the horizontal surface. Now, for this one, we are going to be using the same free body diagram with the axis, the one we draw with the axis here. Now, let's remember that frictional force is equal to kinetic coefficient of friction multiplied by the normal. Guys, that formula is given to you. It is here in the formulas of forces. So we are here. We do have the frictional force, but we don't have the normal force. So where are we going to look for the normal force? Easy. We go into the free body diagram in the y-axis. So we're going to work now with the y-axis here to get that one. So we're going to apply Newton's law to the y-axis, and actually the Newton's law you're supposed to apply in the y-axis is Newton's first law because the object is not accelerating there. So let's apply Newton's first law here. So F net is equal to 0. We're working in y-axis, and I'm going to write up is positive. And you know what? I am going to move all this one a little bit to the left there. So this is important. Now, what forces are acting on the y-axis? We have normal, we have the applied force in y, and we have weight. So it is normal minus the applied force in y. I say up is positive plus minus weight is equal to 0. That is what we have. Up is positive, that's why these two are positive. We're looking for normal. So when you rearrange this one, you will get that normal is equal to weight minus applied force in y. Okay, so if we carry on here, normal is equal to weight. Weight is mass multiplied by acceleration due to gravity. Applied force in y, we do have the formula there, is applied force. Let me fix that one and use the symbol. Applied force multiplied by the sin of theta, which we know is 20 degrees. Okay, so when we substitute here now, we have normal is equal to 50 times 9,8 minus applied force is 300 multiplied by sine of 20 degrees, which is the angle, and then you will get the normal. This one will give you 387,394. I'm going to leave it in 3 decimal places. And now we're going to substitute the normal force in here. So friction, which is equal to 180, is equal to kinetic coefficient of friction multiplied by normal. We got 387 multiplied by 387,394. And guys, then the coefficient of kinetic friction is equal to 0,46. That is the answer. Alright, and the marks here, the marks are going to be 1 for this one here, for this substitution of the normal force, 1 for the formula of frictional force, 1 for this substitution here, and 1 for the final answer. There is 4 marks for that. Okay? Okay, question 2.5. The metal container continues to be dragged with a force of 300 Newton, but the angle is increased. What will the effect of the magnitude of the kinetic frictional force acting on the container? Only write down increase, decrease, or remain the same, and explain your answer in the question. Okay, now to answer this question, let's use maybe this space here. Let's use this space here. And this is going to be question 2.5. Okay, now frictional force is equal to kinetic coefficient of friction with just calculated multiplied by normal. Now, important here, the kinetic coefficient of friction will stay constant. Do not matter what, it stay constant. It's only changed if the surface is changed. The normal force here, this normal force, if we go back to the calculations, we can see that this is equal to the product of to the subtraction of weight minus the applied force in Y. So we have it here. Normal is equal to weight minus applied force in Y. Okay, now important, weight is also constant. You do not change weight. This one is constant. But the angle is now going to be bigger. Okay? If the angle is bigger, the sign of a bigger angle will result in bigger number. So all this one will be greater. Alright? So you are subtracting a constant number by a bigger one, which means the normal will be smaller. The normal will be smaller. And if the normal is smaller, then the frictional force is smaller. So what will the answer be here? It will be decrease, and the result is that one there. So the answer is decrease. And if you say that, you'll get 1 mark for saying decrease, 1 mark for saying decrease. The other mark is 1 for saying that the kinetic coefficient of friction is bigger, and the other one is for saying that the normal is smaller. They are all the marks, guys. This is the end of this question. I hope it helped you write in the exams quite soon. It's a very good question to practice. If you like the question, like the video, subscribe for the channel if you didn't. Next time we'll try to solve a question on vertical projectile motion. Thank you for watching. I'll see you next time. Mr. G here.